My name is Derrick Reish. I'm a senior product manager with LaserTechnology. We come from Denver, Colorado, and our company has been in business about 30 years now. Just a little history about the company. We've done proximity lasers for NASA. That was one of our first lasers we've done. Another thing we've done is worked with Bushnell. It's a company that makes recreational rangefinders. It's a partnership we've been doing with them since about 1994. And then part of this GIS community or surveying community. We designed the first reflectorless total station. The U.S. Forest Service came to us in the early 80s, and we designed a reflectorless total station that gave us distance, inclination, and azimuth, all built into one unit. You can see here to the right. So I'm going to dive into a little bit about the sensor technology before I get into the trends of how we use our instruments in this industry. So LaserTechnology, we specialize in pulse technology or reflectorless technology. A product line we have right now is called the TruPulse 200 360. And what it is a precise time measurement device. It sends out thousands of pulses to the object, bounces back to the device, and we time the pulses going to the object and bouncing back, and with that we're able to calculate the distance. And that is pulse technology. There's no need to have a reflector or a second person with a prism pole. We can get a measurement to almost any type of object at a lot of different ranges. So we can get measurements to trees, utility poles, or a bird's nest here, you see it here. It's all class 1 eye safe, so it's less power than your remote control. Besides this laser sensor we have built inside, we have a tilt sensor. It's a 2-axis accelerometer sensor. We're able to measure the tilt of the unit itself. So we can measure plus or minus 90 degrees, you can see here in the diagram. So with the accelerometer measuring that static acceleration, forces such as gravity, it allows us to become a tilt sensor to measure that angle you see there. So with the laser sensor measuring to the object and the tilt of the unit itself, what we do is we're able to measure that slope distance and measure that inclination. And with those two values, we're able to calculate a vertical distance and the horizontal distance to the object. And that's all with one press of the button, getting those values. So we've got the laser sensor, the tilt sensor. Now we've added a compass sensor in there. Well, the compass sensor, the engineers have done a great job integrating the compass into a small device, as you see here. It's pocket size, handheld, basically a handheld total station. There's no pitch and roll limitations with this device. So no matter how you rotate the unit itself, it's going to maintain that plus or minus 1 degree in azimuth accuracy. So now with that sensor measuring the azimuth, now we can measure to an object. We get our X, Y, and Z. We measure a slope distance, inclination, and azimuth, and all from one position. Now we can get that X, Y, and Z position of the object. So that's the rangefinder, tilt sensor, and the compass sensor all built into one device. So what I'm here today about the technology, that's great. It measures all these different things, but what do I do with this information? You want to integrate it with a compatible GPS and GNSS handhelds. You see here all the different data collectors or GPS devices that we integrate with. You may have some in your back pocket or your toolbox, but these are all the devices that we integrate, all these different Windows mobile devices, even Android and iOS devices that we do integrate with. But what it really comes down to is you've got your GPS device, you have a laser, but how do I collect that data? What I'm going to talk about is the trend using the laser in GIS and surveying applications. So I'm going to talk about these laser offset mapping methods. What is an offset? This is a little clip we've come up with about what an offset is, or a laser offset. It's basically combining the laser sensor values to your GPS location and calculating that remote position. So we call that a laser offset. Measuring that laser offset, well, just what I was describing there. I occupy a position with my GPS. I measure to the object, and with those values the laser rangefinder gives us, the software will calculate a remote GPS position. So I don't have to walk over to each position with a GPS and grab those points. I can stand in one location and map all these different points with our device. So basically stand here, map there, map this, it's productivity. So again, we want to keep it also in safe environments. You don't have to walk across the street or be in the middle of a road. You stand again one location and map all these different points in and calculate them very fast and quickly. So our campaign right now is educating that you already have these devices, but what you just need to do is incorporate a laser rangefinder. And it all really comes down to is that GIS software solution that you have on your data collector. All these different software solutions I'm going to talk about here, they have different mapping methods or offset mapping methods. That might be a different name for your software that you have. You've got distance bearing or complex offset or 1-point offset. And that's where you're going to use a TruPulse 360 model that incorporates that rangefinder, tilt sensor, and the compass sensor all into one. So I stand in one position and map. Another mapping method is the distance. You don't have to have the compass, and you can still do offset mapping. A distance is I'm going to occupy 2 different points and shoot to the feature, like range triangulation. And these are the different names here that might be in your software solution, but where you can utilize one of our laser rangefinders that just does distance and tilt. So what we've done is, over the time, we've identified all the different companies, all the different software solutions that have a laser rangefinder extension built in. You're going to probably recognize a few of these companies here: Trimble, Spectra Precision, Topcon. They're all in this hall today. So you can go talk to these companies and find out that they do have these software solutions that have a laser rangefinder offset method built in. There are a few other companies that are around. We have our partner, Positioning Resources, that has developed their own software that has a laser interface built in. So it's not just in the United States; it's across the world that these these software companies have built in this application into their software. So over time, we go to all these conferences throughout the world. We want to ask end users, what are they using? So we do a GIS poll at all these different conferences that we attend. As you can see here, all the different companies, the Trimble, or all this different software, Digiterra, etc. And you can see how many people what software people are actually using. It is tended to go towards a few, the Trimble, because we do go to a lot of Trimble conferences, and then we also attend the Esri User Conference. But this is where you can see a lot of the different software solutions people are using. So what we broke it down to also is this GIS pool is, what software do you currently use, and what's your biggest challenge? You can see here the biggest challenge down here in poll question number 2, workflow deficiencies, time-consuming training. Well, this is where the laser rangefinder comes into play, is about the workflow deficiencies. You don't have to walk to every spot. Or training, make it a lot easier to integrate a laser rangefinder into that. And the other top one there is time-consuming. If I have to walk to every position, I'm taking time and money. If I stand in one position and do my laser offsets, I can map much faster, quicker, and safer. So we've identified all these different software solutions that we see in the market right now, and what we're to help these end users is we make technical documents. So you can go onto our website, find these technical documents, find your software solution, and it walks you through how to set up the laser rangefinder for your particular software. It's to perform these laser offsets. Basically, what I want to kind of talk about are things to consider. What do I need to know when I'm going to integrate a laser rangefinder into my application or into my workflow? The first one is accuracy tolerances. You got to take a look at what you need. You look at distance, accuracy, inclination accuracy, and the main one is your azimuth accuracy. Our compass, built in our TruPulse product line, is plus or minus 1 degree, and again, it has no tilt or roll limitations. There are other devices out there with the compass. Once you start to tilt it past 15 degrees, the compass is not as accurate. So you got to take those into consideration when you're looking for integrating a laser rangefinder into your workflow. The second one I want to talk about here is cost of ownership. You probably already own these devices. You already own the software. Upgrading into with the laser rangefinder, you can get into doing the application much faster. So you've already done the upfront expense. Now the next thing is just integrating kind of an accessory into your toolbox. And of course, training, time, and those are very expensive. So we broke this down into a chart here of different devices. Your total station, you can see, is the high expense, all the way down to the recreational, which is a very low expense. So it's kind of how that fits into your model. Portability and size, other things to consider. You know, am I out there with a big tripod walking around in the forest, or like want something pocket-sized? User experience. With our unit, we have a 7 times magnification, so you got a wide field of view, and also we have different ways of targeting that object. Other things that help the customer know that they're getting the right accuracy is we have field calibrations. A big thing in the field everybody wonders about is this going to be accurate? Is it accurate for me right now? What we can do is you do field calibrations to ensure you're getting the most accurate measurements and compass. And you can see this, you can either pass or fail on these field calibrations. And that last one we talked about is that workflow efficiency. How can I make the workflow easier, faster, and safer? And by integrating a laser rangefinder into this, it's definitely a way to increase your workflow efficiency. Different applications when you need to be safe. I call this the Doberman factor. I do not want to cross the fence with my GPS to get that position. I can stand on this side of the fence and map in that position instead of crossing that. Or again, like in the middle of a highway or a road. Or when the signal is blocked. Urban canyons, forestry, canopy, etc. Sometimes you don't always get that great GPS signal. You can get in a good location, get that signal, and then move into that location, those canyons, and continue to map. Or when you need to save time and money. I don't want to walk to each one of those power poles with a GPS device. I can stand in one position again, do multiple offsets from one position. Talk about the benefits of this. I've been talking about that through this presentation itself. Work with what you already know. You're the expert with the software. We designed some technical documents you can incorporate the laser rangefinder into your workflow. Or collect different attribute data. Just not the position you can calculate or collect, is also you can collect the heights of trees or heights of buildings or widths of things, spans. This is all you can do additional attribute data with the software solutions. And then enhance your system with lasers. The big thing I talked about is the safety, just map quicker, and save time. Those are the big things utilizing one of our laser rangefinders into your workflow. What I want to end out today is, I made this presentation pretty quick and short, capture your attention. But we have a top secret mission that we've got going on. We're introducing a new product line. We have a stand excuse me, outside in the back. Don't know if it's raining still, but we have a stand outside. You can take a look at our new product that we're releasing. It's called the TruPoint 300. And if you want to go back to take a look at this new product we have, is in the back. And also we have a stand inside if you want to learn more about our lasers themselves, utilize them, or see them integrate with other software solutions. Again, my name is Derrick Reish, LaserTechnology. I appreciate INTERGEO today and the Trend and Medium Forum allowing us to come up and do this presentation. But if you have any questions or want to do any hands-on demonstrations, we're inside the booth here, just right inside Hall C, booth number 39. We can talk about. I can show you some more devices, and you get some hands-on demonstrations. So I want to again thank INTERGEO and thank you very much.